When it comes to the way hypertension develops, there are a number of different factors. And in order to fully understand the factors, we have to do some math because, math is always fun. So let's talk about cardiac output. Cardiac output refers to the amount of blood that each ventricle is pumping per minute. And in order to calculate cardiac output, we need to take two factors into consideration. Number one, the heart rate. So that's the number of beats per minute. And we're going to multiply that by the stroke volume. That's the amount of blood that each ventricle is pumping with each contraction. So let's take some simple numbers here. Let's say I have 70 beats per minute, so 70 BPM, and I multiply that by 70 milliliters. I am going to get, let's say, 4.9 liters. What's the significance there? Well, when we come to blood pressure, let's do that in a different color. Let's use yellow. Blood pressure can be determined or calculated by taking cardiac output and multiplying that by peripheral resistance. We already spoke about this cardiac output, but peripheral resistance deals with the amount of resistance to blood flow. If there's an increased resistance to blood flow, it's harder for the blood to get through the vessel. That is an increase in peripheral resistance. And if you increase any of these two factors, if you affect any of these two factors, you're gonna affect blood pressure. Now, usually when we're dealing with hypertension, the main cause of increased blood pressure is going to be your peripheral resistance. There's something that is affecting the ability of the blood to flow through those vessels, and that is going to increase your blood pressure. And the main reason for that is increased arteriolar vasoconstriction. And we spoke about this a little bit in the previous video. So increased arteriolar vasoconstriction. I want you to understand this. So let's draw some arteries here. Here I have an artery, and I'm drawing that artery very simply. And this layer that I'm showing in white is going to be my endothelial layer. And then surrounding that, we're going to have another layer. And that layer is actually going to be a smooth muscle layer. And anytime you hear muscle, you should think that there's contraction that's possible, right? So if there's increased sympathetic activity, so I'm just going to put symp act. Increased sympathetic activity, the sympathetic nervous system is releasing norepinephrine and epinephrine, basically adrenaline. That is going to cause constriction or contraction of that smooth muscle layer. And as a result, what's going to happen is the lumen of the arteries is going to get significantly smaller. So you see you have less space here. Now, what does that do? If you have two tubes and one is wider and the other is narrower, which one is going to be easier for water to flow through? Of course, the wider one, because there's more space. And that's the same way it is with the arteries. If the arteries are narrower, you're going to have more resistance to flow, increased peripheral resistance, and as a result, that's going to cause an increase in blood pressure. There are other factors that come into play, and to show that, let's get rid of this stuff. If there's increased peripheral resistance, that is going to make it harder for blood to flow to the destinations that it needs to go to. And as a result of that, one of the places we're going to see that effect is that there's going to be decreased blood flow to the kidneys. Should I try to draw a kidney here? Sure, why not? My drawing is not the best, but let's say that's a kidney. Let's just imagine that that's a kidney. As a result of that decreased blood flow to the kidney is going to release renin. And that renin is going to have a number of effects, two main effects. And what I'm describing here is going to be called the renin angiotensin system or mechanism. And we're going to have two different pathways that are going to be at play here. Pathway number one is going to be that renin is going to cause angiotensinogen, and I'm going to do it in 2 lines so that it doesn't take up too much space. Tensinogen, angiotensinogen, I can't speak, to be converted into angiotensin 1. So let's just put Ang1. Angiotensinogen is going to be a protein, an inactive protein that is produced in the liver, and that then gets converted to angiotensin 1 when the kidney releases renin. Then there's an enzyme that is going to convert angiotensin 1 into angiotensin 2. And the name of that enzyme, let's do that in orange, is going to be ACE. And that stands for angiotensin converting enzyme. It converts angiotensin 1 into angiotensin 2. And the significance here is that angiotensin 2 is going to be the most potent vasoconstrictor in the body. And of course, with increased vasoconstriction, what is that going to affect? That is going to affect peripheral resistance. That's going to cause an increase in peripheral resistance. This should sound familiar. I'm going to draw a square around that because that is very significant. Renin also has another effect, and we're going to do that in a cyan color. And that is, it's going to cause the release of aldosterone. And the significance with aldosterone is what that is going to do is it's going to cause an increase in sodium ion reabsorption, and as a result of that, also H2O reabsorption. So what's going to happen is it's going to cause an increase in sodium ion reabsorption, and the water is going to follow that sodium ion. This is all happening in the kidney, and one of the main functions of the kidney is to filter the blood and to produce urine. So we're getting rid of waste, and regulating the amount of water that leaves the body is very important in maintaining fluid balance in the body. Okay, so if you're reabsorbing more water into the body, that is going to cause an increase in blood volume. So the volume of the blood is going to increase. And as a result of that, if you have more blood, an increased blood volume, when the heart contracts, it's going to be sending more blood. And yes, you guessed it, that is going to cause an increase in cardiac output. These both should look very familiar to you right now. And in red, I am going to show you that these two factors are going to result in what? An increase in blood pressure. How do we know that? Because we looked at that handy dandy formula that was BP is equal to, you should be reciting this with me, CO times PR. And because of that decrease in blood flow and that renin release, we're activating these two different pathways that are going to result in increased cardiac output and increased peripheral resistance, which in essence increases your blood pressure. Now, here's the problem. If you're increasing blood pressure even more, that can cause even more damage to the blood vessels. And as a result of that, we can draw an arrow that's going right back here, because if we're damaging the blood vessels, we also have sympathetic activity that's happening. That is going to cause a reduction in blood flow to the kidney. And you can see that this is a cycle. And this is why hypertension is such a terrible thing, because it kind of feeds on itself and makes itself worse. And in order to stop it, we need to stop this at one of these points, depending on how bad it is. So there are a number of places that we can stop this process, and that's exactly what we want to do.